What is a sensor? A sensor is a device that measures or detects any real-world conditions such as heat, motion, light, and converts it into an analog or digital representation that can be easily understood. Ever wondered what could actually happen if your system does not have any sensor? Excessive heating can potentially damage and burn the electronic components or circuits of your computer. It can cause system to lock up, crash or freeze unexpectedly. Computer designers took great effort in ensuring that the system runs properly by embedding different kinds of sensors. First, let's have a look at temperature sensors. Temperature sensors are fundamentally diode junctions embedded in their related chips. The temperature sensors are located on several locations inside the computer, such as the motherboard, inside the CPU, or below the CPU, inside the GPU, or inside the hard disk. One such temperature sensor is the DTS, digital thermal sensor. Recent computers have processors equipped with DTS that measure the maximum temperature on the die at any given time. DTS regulates the system and processor fan speeds. 2 DTS per core are now placed at vital processor positions, closer to the hotspot, allowing for quick and accurate temperature readings. Depending on the processor temperature, the system can be accelerated or slowed down by the user or automatically. There are plenty of softwares which enable users to monitor and utilize embedded sensors. One such utility is the HW monitor. It is a freeware from CPU ID that reads system's main health sensors like voltage, temperature and fan speed. It handles common sensor chips and reads on-die core and hardware drives, video cards, graphic cards and temperature. Another utility is the speed fan. The speed fan is a program that monitors voltage, fan speed and temperature in computers with hardware monitor chips. It can access the DTS and can also change fan speeds to reduce noise. It can find almost any hardware monitor chip connected to the 2-wire SM bus. It is even possible to change the FSP on some hardware using SpeedFan. The PC probe. It is a simple utility that monitors vital information in computer such as fan's rotation, speed, voltage and temperature. It also gives additional information such as hard disk space, memory usage, etc. The application resides in the taskbar and provides audio warnings if threshold of temperature and voltage have been exceeded. Let us explore one utility called the speed fan. As you can see, we have a Pentium dual-core CPU running at 2.7 GHz. The utility shows the reading of the fan speed running at 3386 RPM. Since we have only one fan, the rest of the fan speed readings are default set at 0. In the temperature area, the temperature recorded by the different sensors on the motherboard are shown as Temp1, Temp2 and Temp3. The hard disk temperature are shown as HD0 and HD1. The temperature of CPU is shown as Core 0 and Core 1. All these temperature values are changing dynamically. In the clock tab, we can change the clock speed of the motherboard. Carefully, we can change the motherboard and the clock settings. But be careful, if you choose the wrong motherboard or clock, you can damage your system. Now, in the exotic tab, you can show the system's main health sensors. The exotic tab, apart from showing temperature values and fan speed, it also shows voltage used by various chips like VRAM, VChipset, etc. It also shows the frequency and the uptime. Now using the smart feature. The smart feature or self-monitoring and analysis reporting technology is a monitoring system for computers' hard disk drives. It detects and reports various indicators of reliability. When a failure is anticipated by SMART, the user may choose to replace the drive to avoid data loss. The smart feature can also be used to detect external drives. As we have an external hard disk attached, we can choose from the drop down menu and see the various features of the hard disk. In the Charts tab, we can explore the temperature of various components by analyzing their graphs. You can see by selecting
That was all about Windows. Let's see what are the utilities in Linux to access the temperature sensors. Some of the applications that can be used in Linux are HDD temp, LM sensors, P sensor, etc. First, we have to install the LM sensor package. Go to the terminal and type sudo apt-get install LM sensors. Type the password. The package is installing. After the successful installation, type sudo sensors detect in the terminal. A program will run which will help you to determine which kernel modules are needed to use LM sensors effectively. For example, south bridges, CPU, memory controllers, and input-output chips contain embedded sensors like silicon integrated system, digital thermal sensors, etc. Modules needed to scan them will be loaded effectively. We can probe the SM bus adapters for connected hardware monitoring devices. And we install all the modules. At the end, a summary of the scanning done will come. We find that in our system, we have a Intel digital thermal sensor for measuring the core temperature. Now type sensors in the terminal. This shows the temperature of the motherboard as temp1, which is currently at 56.5 degrees Celsius. The temperature of the two cores is shown as core 0 and core 2. By typing sensors -u in the terminal, you can see, along with the other values, the maximum and the critical limit specified for core 0 and core 2. By typing sensors -f, you can see the temperature in Fahrenheit. You can also go into the man pages of sensor to see the various options for sensors, like sensors -c to specify a configuration file, sensor -l, it will print the help text, sensors -f, it will print the temperature in degree Fahrenheit instead of Celsius. Now we will talk about X sensors. X sensor is a graphical interface utility that shows the motherboard and the CPU temperature. X sensor uses the reading generated by the LM sensors and just shows them graphically. You can access X sensors by typing X sensor in the terminal. As you can see, the motherboard temperature is 55.5 degrees Celsius. The core temperature is also seen in X sensor. You can find values shown by X sensors change dynamically. Now let's see P sensors. P sensor is another graphical interface utility. It is a temperature monitor which shows the temperature of the motherboard, the CPU cores, and also shows the CPU usage. We can see the graph of the temperature plotted by the sensor package. If we open some tabs in Firefox, a Word document, a presentation, and a video, we will find that the temperature reading shown by P sensors increases. As we open these things, load will increase on the systems, which can be reflected through the increase in temperature. This shows as the CPU uses.
An accelerometer is an electromechanical device that measures acceleration forces. These forces may be static, like the constant force of gravity, or they could be dynamic, which will be caused by moving or vibration of the accelerometer. Some accelerometers use the piezoelectric effect. They contain microscopic crystal structures that get stressed by accelerative forces, which causes a voltage to be generated. Another way to do it is by sensing changes in capacitance. If you have two microstructures next to each other and they have a certain capacitance between them, and if an accelerative force moves one of the structures, the capacitance will change. The conversion of capacitance to voltage will result in an accelerometer. Accelerometers are small motion sensors inside the tablet PC that detect the orientation of the device. As the user rotates the tablet PC from landscape to portrait mode, the accelerometer detects the change and causes the tablet PC operating system and the software to respond by adjusting the display to match the new orientation. Accelerometers can also be used to interact with certain applications and games. By tipping the tablet PC in a certain direction, you may be able to instruct your game character to move in that particular direction.
In the computing world, many companies have recently started using accelerometers in laptops to protect hard drives from damage. If you accidentally drop the laptop, the accelerometer detects the sudden free fall and switches the hard drive off so that the head does not crash into the platter. In a similar fashion, high G accelerometers are the industry standard way for detecting car crashes and deploying airbag at just the. Now let us take a look at some of the utilities that help us to access and utilize these sensors. Because the modern day computers do not have many accelerometer sensors, we'll step into the mobile world to see the real application of accelerometer sensors. There are hundreds of utilities that we can use to explore these sensors. Let me show you a very basic primitive application of accelerometer sensors. It can alternate the view of the screen depending upon how we hold it. As you can see, after I select the auto rotation feature, when I hold my mobile phone in different orientations, it automatically senses the change and aligns the phone accordingly. Let me show you an application by the name of accelerometer frequency. This application is used to simply display the accelerometer information and the frequency of the different accelerometer events. As it shows, my mobile phone has an accelerometer sensor from the company Bosch with the model number BMA222. It also displays the power and range of the resolution. In the frequency tab, we can see the frequency of the clock of my accelerometer sensor with minimum, maximum, mean, and other such values. Another useful application to measure accelerometer sensors is the AC meter or accelerometer meter. It helps us to measure the tiltness, vibration, and the speed of the phone as sensed by different accelerometer sensors. As I tilt my phone in a particular direction, the red dot moves accordingly, showing that the degree of tiltness is being very aptly measured by the sensor. This is widely deployed by motion gaming these days, where you simply tilt your phone in different ways to control the character and the flow of the game. The vibrations experienced by the phone in different directions can be easily seen through the graph. As I move my phone in different directions or as it experiences different vibrations, the phone
sensor automatically senses these vibrations and shows them on a graph. We can also use this application to show the readings of the speed sensor inside my mobile phone. The speed sensor is based on just lateral and frontal acceleration. You can measure the speed of moving vehicles through this sensor.
Let us see what happens inside an accelerometer sensor. I made this model of a sensor. Please note that this is not how exactly the sensor works, but it can give a fair idea about how things may be happening inside the sensor. It's a needle attached in a mass which is suspended freely. It gets disturbed from its mean position whenever it receives any disturbance like vibration, tiltness, acceleration, etc. The needle sends out magnetic field signals or electromagnetic waves, which is received by small receiver sensors on the other end, located at different positions. There may be many receivers concentrated in a small region. The motion is converted into electrical signals by sensing the changing magnetic fields. This is the Hall effect on which many accelerometer sensors work. Apart from these sensors, there are many other sensors in recent computers, mobiles, and their peripheral devices, like gyrometer, which is used in mouse, which measures or maintains orientation on the principle of angular momentum. Magnetometer sensors, which measures strength or orientation of magnetic fields. GPS sensors in laptops, which collect real-time latitude, longitude, altitude in conjunction with other sensors. LCD sensors, which manages multi-touch, automatic screen brightness, etc.